Good day and welcome back to the Hopkins demonstration forest. This is part 3 of a series on what is a forest. Today's topic is going to be talking about the two parts of a forest, the living and the non-living. We have a special term for the living. We call that the biotic, and the non-living, the abiotic. So what are those two parts of a forest? Well, let's start with the abiotic, the non-living. If I look around down here, can find a chunk of the non-living. Well, it's also in my eyes right now. The sunlight, that is one part of the non-living part of a forest, that energy coming in, but also the rocks, the minerals that make up parts of the soil, non-living. Well, if it wasn't such a fine day, the water that would be coming down from the sky, but also the water that's flowing under our feet right now as we walk in our forest. So, non-living, sunlight, rocks, minerals, water. Now how about the living? Well, that's kind of pretty obvious. I think you can imagine the plants that are growing out here, the animals, even the ones we don't like so much, the bacteria, the fungus, some of those decomposing little mushrooms that are out and about in the forest. Those are all part of that living piece of our forest. So with those two parts, the living, the non-living, the biotic, the abiotic, we can start talking about how a forest functions. Because when you mix those up a little bit, you can create different kind of areas in a forest. And I picked this area kind of in particular for this video because it has kind of a unique feature. If you look around my feet, there's lots of little rocks. And if I were to kind of scavenge around a little more, I'd find some bigger ones. This is a very rocky area. That rock, that non-living part, kind of creates a unique feature. And those unique features, where the living and the non-living work together, we call those ecosystems. An ecosystem is an area that includes all of the functions of the living and the non-living. And so you can imagine as we kind of go from one area of the forest to the other, things might change. Let me use a real extreme example. If I were to go down this hill and eventually walk down to our pond, that pond has a very unique area, a boundary. I could walk around it. One side is very wet, has a lot of that non-living water, and on the other side, a little bit more dry, has more soil, even part of the non-living, but might have some organic. So that water area, that pond, is a very unique feature. And inside that unique feature contains living and non-living functions. So that abiotic and biotic relationship between in that pond, the frogs, the salamanders, those macroinvertebrates, they all kind of live together, and some of them will never leave that area. So that's a very unique area or an ecosystem. So up here on the hillside, kind of the opposite. A very rocky patch that I picked. It has some kind of unique trees. Here is a Pacific madrone, and behind me are actually several. And you can see the big boulders that come down through. Very rocky, very dry. Water in the summertime is very limited here. So water that comes down from the sky stops for about 3 or 4 months during the summer. And that water, by the time that month or two of dryness in the summertime comes along, it's long gone. So a lot of the plants here are used to that. And if we were to walk down the hill a little further, we start noticing the change in vegetation. So these ecosystems are very special places that contain a combination of interrelated living and non-living function. But also the forest is made up of multiple ecosystems. And that gets us to the next layer about an animal's habitat. So some animals like a very unique, special place. But some animals require multiple ecosystems. So if we think about going back to that pond, think about a fish. It's about all that fish really wants. Doesn't want to come out and go for a walk through the meadow or a stroll down through the forest to get its food. It should, if it's functioning right, have everything it needs in that area if that ecosystem is healthy and the abiotic and biotic functions are working together. But now take a deer. If I were to put a deer in that pond, deer would not be happy, right? So pretty obvious, but that deer needs that pond for part of its habitat need. What does a habitat or a wildlife need? Food, water, shelter, and that right environment and space. So a deer might need a pond, a special unique ecosystem, but it also might need a young forest to go and find forage and eat in. It might need an older forest, or like the one up behind me, that has lots of different layers for shelter, to hide or to get protection from the wind and the cold weather, or even those summer heat waves we get. So between the non-living and living functions of our forest, we create these unique places called ecosystems, and those ecosystems create larger areas of habitat and the expanse that spreads across the state. Again, I said 30 million acres last time, 30 million acres, half of our state covered with forests. Every step you take across that forest, notice things change quickly. And some animals require a very special place. Some require a lot of special different places to make up their habitats. But ecosystems, habitats, and Oregon's forests are pretty awesome because they provide us what we have and enjoy every day. So you keep getting out there and enjoying, and I hope to see you soon. Thanks a lot.